Hello, Chemistry 10HH students. This is Mrs. Altman, and we are on Types of Chemical Reactions, Part 6, video number 31. Here are our objectives for today's video. Pause here. So if we haven't already, we are going to do this in a lab. This is a titration. A titration is an experimental technique that we're going to be using to determine the concentration of a substance in a solution. So for example, if I have let's say 25 milliliters of vinegar and I want to know the acetic acid concentration of that vinegar, titration is the experimental technique I would use in order to determine the concentration. I would take the vinegar, I would place it in an Erlenmeyer flask. I would take some sort of base, typically sodium hydroxide, I put it into a burette, and then I would add sodium hydroxide to my acetic acid until the reaction was complete. The goal of this video is to be able to do the calculations with it. I am going to demonstrate and show you how to do a titration in the lab. It's actually my favorite lab to do with students. I think it's such a cool lab. So we'll do that physically together in the lab, but our goal here is to figure out how to do the calculations. They're just stoichiometry calculations, but with a couple of steps we haven't necessarily done all together before. Pause here. So there are a couple of assumptions that we need to make before we do titration calculations. We're going to assume that we will always have a 100% yield, so we're not going to have anything less than 100%. This is true pretty much for any time you're reacting a strong acid or a strong base, even if you're reacting it with something that's weaker. And then we are assuming that any water that we generate in the reaction, since these are neutralization reactions, the quantity is negligible. It's not going to be affecting any of our concentrations. Pause here. So just like any other stoichiometry calculation that we've done this chapter, we are going to start by getting the balanced chemical equation. And now this is asking for moles of molarity rather of HCl. So that means I need to get moles over liters. So my first step to getting moles is going to be starting with the sodium hydroxide. So this will be a little bit unusual in the sense that I am going to actually round between steps here. Oh, actually, I don't know why I did 1,000 milliliters in the bottom. That should be 1 mole NaOH. You don't actually have to round between steps. Any small sort of differences that come from this are going to be negligible. And then the question told us that we had 35.4 milliliters. So then I just convert that to liters. Round that to sig figs. That is all for today's video. Thank you so much for watching and have a great night.